Okay, we're going to look at a couple of trig identity questions. First one, this question says, using the identities sine squared a plus cos squared a equals 1 and or sine a is equal to sine divided by cos, prove that. And the first proof we're going to look at is brackets 2 sine theta minus cos theta all squared plus sine theta plus 2 cos theta all squared is equal to 5. So the idea of these identities is you work with one side only until it is equal to the other side. So the nice way to say this is LHS, which stands for left hand side. And what I'm going to do is expand these brackets out. So big mistake people make is not doing what I'm about to do now, and then they make mistakes when they expand the brackets. So this is what we've got. We've got our sine 2 theta minus cos 2 theta squared. So that means sine 2 theta minus cos 2 theta upon sine 2 theta minus cos 2 theta. Then plus, we had a sine theta plus 2 cos theta upon sine theta plus 2 cos theta. Now there's all sorts of weird and wonderful ways to multiply these out, but I just like to go 2 sine theta times 2 sine theta is going to be 4 sine squared theta. And I'm also going to have multiply that out again. That's going to be 2 sine theta times a minus cos theta is minus 2 sine theta cos theta. And then multiply this one out. That's going to be minus another 2 sine theta cos theta. And then minus times a minus is plus, and it's going to be plus cos squared theta. I'm going to move on to the next line just to do this because it's just going to be too long a line of working out. Sine times sine then over here is just going to be plus sine squared theta. Sine times 2 cos theta is going to be plus 2 sine theta cos theta. And then over here I've got another plus 2 sine theta cos theta. And last of all I've got plus 4 cos squared theta. Okay, that is an absolute mess. Let's tidy it up. And what we have, what you will see, I'm just going to use the green pen here and see I've got a minus 2 sine theta cos theta and I have a plus 2 sine theta cos theta. It'll cancel out using the red then. You can see this minus 2 sine theta cos theta and this plus sine theta cos theta will add together, or so will cancel out I should say. And then what we also have, and I'll just highlight these ones, we've got 4 sine squared theta, and we have another positive sine squared 1 sine squared theta, so that's a total of 5 sine squared theta. And then in the blue, we've got cos squared theta, and we've got 4 cos squared theta, so that's a total of 5 cos squared theta. Okay, still looking where we're trying to get to. We're trying to get to equal this whole thing to be equal to 5. So we have a tiny wee bit to do yet. So what you can do is factorize out a 5 here, and you're left with sine squared theta plus cos squared theta. And we know up here, we know that sine squared plus cos squared is equal to 1. So that's just 5 upon 1, which is equal to 5. And a nice way to finish this off, just say that is equal to RHS, which stands for your right hand side, and you know you've got the full marks. So that's a lovely place to be. Okay, next example. This is a bit of a strange one, to be honest, the way they have written this out. Now what they've said is this expression, cos squared a minus sine squared is equal to cos squared a minus 1. And then which is also equal to this thing. So I'm going to take this in 2 bits. I'm going to sort out this bit here. This yellow bit is equal to the left hand bit is equal to the middle. So I'm going to sort that out. Oops. We'll sort all that out first. So I'm going to say my LHS is equal to, so that was my cos squared a minus sine squared a. And look at where I'm trying to get to. I'm trying to get to this thing which has got no sine squareds in it. So I'm going to change my sine squared somehow so I get rid of them and they become cos's. So we will say, we know, that, pardon me, cos squared a plus sine squared a is equal to 1. And then if we rearrange that, we can find out that sine squared a is equal to 1 minus cos squared a. And we're going to sub that in. So in here, we're going to rewrite our sine squared a as 1 minus cos squared a. And then that will become, if we multiply that out, cos squared a minus 1, and then minus times a minus is plus cos squared a. And there we have it. We've got 2 cos squared a minus 1, which is what we had wanted. Happy days. That is it. Okay. Next thing we're going to do the same thing. And again, I'm going to see how I can change this so that it becomes this. So I'm going to work with my left-hand side again. We're going to go and get rid of that. Look at the left-hand side again to start us off. So again, we'll just say our left-hand side is equal to cos squared a minus sine squared a. And it's going to be a very similar thing. So we're going to just say, remember again, cos squared a plus sine squared a is equal to 1. So this time, look where we're trying to get to. We're trying to get to here. I always say keep one eye on the prize. Look at where you're trying to get to. So we're trying to get to an expression which has got no cos squareds in it. So we need to change our cos squared. So change how cos squared appears. So if cos squared a plus sine squared a equals 1, that means cos squared a will be 1 minus sine squared a. And then we can sub that in. So this becomes, instead of cos squared a, we're going to write 1 minus sine squared a, and then minus sine squared a, which then becomes multiplied to bracket. You'll just have 1 minus sine squared a minus another sine squared a, which then becomes 1 minus 2 sine squared a, which is what we had on our right hand side. So we can see it is correct. So we have shown basically our left hand side is equal to this thing eventually, and we have shown our left hand side is also equal to this thing. So we have shown our left hand side was equal to this thing, and our left hand side is equal to this. So it's simultaneously equal to these. So these 3 things we have in these circles, they all have the same value, I suppose you could say, or the same worth, but they just are different ways of writing the same expression.